All right, welcome back. Now in this particular video, we're going to see how we do feature extraction. All right, so previously we have gotten introduced to some concept in convolutional neural network, and what we want to do in this particular video is to see practically how we extract features using convolution and using the concept of convolutional neural network, okay, which is also referred to as ConvNet or CNN. Okay, so we're going to see a practical demonstration over here. All right, so let's get started. All right, so we said that the main idea that we are trying to do over here, right, when it comes to convolutional neural network or ConvNet, what we're trying to do is to connect patch, okay, connect patch. So a certain patch of the image instead of all the image, right? We want to connect just a certain patch of the image to one neuron, okay? Because traditionally in our fully connected, right, fully connected neural network, we take all these pixels at once and then feed it to the just one neuron over there, okay? So in your data set, you could have maybe thousands of images, okay, thousands of images, and each one of these images might be 1,000, right? Maybe 1,000 cross 1,000, right? Or 500 cross 500. I'm just giving a hypothetical value over there, okay? Something like this. So each one of these ones will have something like that, the size like this, okay? And then you need to feed these images, right? You can call this one as say x1, x2, x3, something like that, okay? You need to feed this one to say the output neuron, the input neuron, okay? You need to feed these things to the input neuron, and imagine each one of these things is coming with 1,000 cross 1,000 matrix, okay, which is just 1 million, which is 1 million parameters just for this neuron, okay? For this neuron, this one too will come with its own, right? So imagine if you're doing fully connected, imagine how many neurons you are how many parameters you have to train, okay? A whole lot. So what we're trying to do, right, what we're trying to do in this case is to just pick a patch of it, okay? Instead of the entire, right, instead of the entire image like that to the neuron, you just pick just a patch of it which you concentrate and then extract information from that patch, okay? You feed only that patch to the neuron. All right, okay, so that's the main idea for this convolutional neural network, okay? That's the main idea. Now let's say that I have this 4x4 filter size, okay? So I have a filter size of 4x4, okay? 4x4, okay, which together will give me like 16 weights, okay? So this is the filter, okay? This is filter, all right, and the filter size is 4 cross 4, okay, which together will give me 16 weight over there. Now I want to put this weight, now I want to put this filter on top of this image that I have, okay? So this is my image that I have converted to a form of a matrix. Remember, the computer only see the image as a matrix, okay? So that's why you're seeing this grid over here, right? And I'm saying it's an image because it's an image which has been converted to a matrix, okay? Which has been converted to a matrix. Right, so you can think of this one as the entire matrix is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Okay, so you can think of the entire matrix as 14, right? 14 cross 14. Right, let me see if this one too is 14. 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Yeah, you can think of it as 14 cross 14. So the entire matrix is 14 cross 14. So instead of feeding the 14 cross 14 to just the neuron, right, like feeding the entire 14 cross 14 to one neuron, what I want to do is to just select a patch of it, okay? So 4 cross 4 instead, and then for the weight that I've specified here, right, I put this weight on top of that one, then I do element wise multiplication, then I'll have a certain value which I'm now going to feed it to that one neuron, okay? So you can see that I am finding a way to reduce the congestion that will come into this neuron, okay? So let me show you how we do that. So I'm going to move this 4 cross 4 filter on top of the patch space that I've selected over here. So if I do that, right, it's gonna be something like this, okay? So I have the 4 cross 4 filter on top of that patch place that I have over here, right? So I'll continuously doing that, right? I'll continuously doing that, shifting it by say 2 pixels, okay? So this one, these 2 pixels, I just determine it as 2 pixels. It could be 3, it could be 4, it could be 1, right? But in this case, I'm saying 2 pixels. So in this case, if I shift it this way, okay, so you can see that I left 2 pixels over there, right? I skip 2, right? I skip 2 pixels, then I move it. So in this case, if I want to move it again, I'll skip these two, right? I'll skip these two, right? And then I'll move it again, right? I'll move it again like that, right? And I'll move it again like this. Okay, let me change this pen so that you get to see it well. Okay, if I am to shift it again, leaving 2 pixels, right? It's gonna be like that. Okay, so next, if I'm to shift it again, then I'll leave another 2 pixels, right? I will leave another 2 pixels, which is going to be 1, 2, right? So it's going to start from here, right? Like that. Okay, so if I'm to do it again, I will leave another 2 pixels, which is 1, 2, right? Then the next one will start from here. Okay, the next one will also start from here. So by doing so, I will be able to capture. So if I'm to leave another 2 pixels, then I will leave 1, 2, right? Then it will start from here, right? And then finally to cover everything. Okay, like that. So that's how I continuously shifting it, right? I continuously shifting it like that. Okay, so depending on the number of pixels that I want to shift, okay, it's how I'm going to shift this filter throughout, right? So I'll do it throughout. So I finally capture the last pixels over here, right? I finally capture the last 4 pixels over there, right? So in that case, the value of this the element wise multiplication of the filter and the patch over there, right? The result of that is going to be fed into this neuron over here. So the entire image could be reduced to this size. Okay, by doing so, the entire big image, which is 14 by 14, okay, 14 by 14, like that, could be reduced to this result of this image, right? 1, 2, 3, 4, 5, 6, okay, 6 by 6, like that. All right, it could be reduced to this form. All right, so in this case, I specify filter, and I say the filter size is 4 by 4. Okay, so I say the filter size, all right, filter size is equal to what? 4 cross 4. Okay, so later on, if you hear filter size, we are talking about the size that you want to specify and go and put on that that space over there. Okay, so if I specify filter size of 4 cross 4, right, then it means that the patch over there, I'm going to put it on a 4 by 4 patch over there. Okay, I need a space of 4 by 4 patch over there, right? Let me get rid of this one here, and let me go back here. Okay, if I specify 4 by 4, or 4 by 4 filter, right? So this is the filter. Okay, this is the filter, or kernel. Okay, or kernel, right? So if I specify the filter size or kernel size, okay, so you can call it filter size, right? Filter size, or you can call it kernel, right? The kernel size. Okay, so here we have specified to be 4 cross 4. Okay, let me shift this one here, 4 cross 4, right? Or if you can call it kernel size, which is the same thing, right? 4 cross 4. So if I specify the filter size to be 4 cross 4 or the kernel size to be 4 cross 4, then I will need a space over here to be 4 cross 4 to put it on, right? Because I cannot specify 4 cross 4 here and go and put it on this 5 cross 5 space over here. It doesn't work that way. Okay, the patch over here will not match, so it should be the same. All right. And this too, the way that I was moving, right? The way that I was moving over here, I say I'm shifting by 2, right? So the shift that I'm doing, right, moving from here to the next, right, is what we refer to as stride. Okay, the shift that I was doing is what is referred to as stride. Okay, so you will have a stride, right? Stride of something. So you need to specify the stride, right? And in this case, we say the stride is equal to 2. Okay, you need to specify the stride to be something. So if we go back here, right here, we shifted to, okay, we shifted to, let me push this one here, right? We shifted, we left 2 pixels over there, right? And then we came to the next one, right? So if I'm to do it again, as I said, I will also leave 2. Since I've specified the stride size to be 2, I will also leave 2 here and then start from here, okay, and then move. Okay, I'll start from here and then move like that. Okay, so if I'm to do it again, I will leave 2 over there, right, and then start from the next, right, like that, and then move. Okay, so if depending on the stride size, okay, depending on the stride that you are specifying, so if you say stride equals 2, then you're going to move 2 times, right? if you say stride equals say 4, then you need to jump 4 times. Okay, 1, 2, 3, 4, and then you put it over there, right? You put it over there. That's how it's gonna be like. Okay, so depending on the stride that you are specifying, that depends on the number of steps that you will take. Okay. All right, so we have gotten to know 4 things over here, right? One is the filter. What is filter? We've known the filter to be what we specify to go and put on top, right? That is what will contain the weight that we want to multiply the size of the various pixels with, right? To generate the next value to feed into the neuron. Okay, so we've gotten to know what filter is, and then we've also gotten to know what filter size. Okay, filter size is. Okay, filter sizes, and then we also know that the filter is also sometimes called kernel. Okay, so the filter size can also be referred to as kernel, right? Kernel size, the same thing, right? And then we also got to know what is stride. Okay, we also got to know what is stride, and we say that the stride is nothing but the steps that you take. Okay, the steps that you take. That is how you move, you shift around, right? So the steps or the shift. Okay, how you shift this filter around is the stride. Okay, and then we also got to know that you can specify the stride that you want to take, or the shift or the steps that you want to take. Okay, or the jump, right, that you want to take. So you can take 2 or 3 or 1 or whatever that you want. Okay, depending on the specifications. Later on we'll see how to determine these things. Okay, so these are the concepts that we have gotten to understand so far, right? Now when you're doing this, right, in order to come up with a value which will represent this new neuron over here, right, that kind of operation that you're performing, right? For instance, there will be some value over there on the patch, right? On that patch space, there will be some pixel value over there. So maybe the pixel value over there is 2, and then you have also specified some values in your filter. Okay, so in the filter you can have something like 1, 0, 1, right, and then maybe 0. Remember the size is 4, so you should have 4 values there, right? Then maybe you can have maybe zeros, 1, 0, 1, something like that. Okay, and then maybe another, so just like that all the way to the last one. Okay, so there's a value on the patch, and then there's a value on the filter, okay, which you're going to do element wise multiplication. So for instance, 1 times 2 will give you something, plus say 0 times whatever value that is also there. So maybe on the patch there's 3 there, so maybe 0 times the 3, right? So plus something like that. So this kind of operation that you're doing is what is referred to as convolution. Okay, what is referred to as convolution. Now it might sound confusing for you, right? It might sound confusing for you, so I'm going to actually take you through step by step how these calculations are done, right, so that it will become clear to you. All right, this one I just give you an overview of it, so if you're a bit confused, that is normal. I'm going to take you through step by step so that you get to know how this calculation is done. Okay, so let's see how we can do it with an example over here, with a demonstration over here. Okay,